In today's video, I'm going to show you how to solve this problem. This is a problem on simple electric circuit. Let's look at the problem. So two resistors, R1 and R2, are in parallel with a potential difference, V, across them. What is the total power dissipated in this circuit? Is it A, B, C, or D? Let's look at the solution. So to solve this problem, we have an electrical circuit of two resistors that are connected in parallel. So we have R1 and R2 with both of their terminals connected to the same node. And then they have a potential difference, V, which is across. And we know in parallel circuit, the potential across each component is the same. So if you look at this circuit, we have the positive terminal and the negative terminal. So if we close this key such that we have a closed circuit, what happens is that conventional current is going to move from the positive terminal because it has the higher potential through the circuit. So this is the total current I. However, at this junction, part of this current is going to go through R2. So let's call that I2. And then the rest will go through R1. So let's call that I1. So in that case, we have the total current, which is I, to be equal to I1 plus I2. So this is one important thing we need to take note of. The next thing to note is that the total resistance for this circuit, okay, is given such that for a parallel circuit, the effective resistance is given as 1 over R effective is equal to 1 over R1 plus 1 over R2, okay? So if we have more resistors that are all connected in parallel, then we are going to have plus all the way to the 1 over Rnth resistor. However, for this circuit, what we have is just two resistors, R1 and R2. So in that case, we have just 1 over R1 plus 1 over R2, and that gives us the effective resistance. All right, so for two resistors in parallel, we do have the effective resistance to be calculated from this formula. When two resistors are connected in parallel, then we have 1 over the effective resistance is equal to 1 over R1 plus 1 over R2. The power dissipated in this circuit, that is the electrical power, is given by P is equal to the potential difference across the circuit times the total current. So with this, we can find the power, all right? However, from Ohm's law, we know that the potential difference is equal to IR. So here we can find that current, okay? And which is the total current. So the current is going to be I equals V over R, okay? And this R here, this I is the total current. This R here is the effective resistance for the whole circuit, okay? We can plug this I equals V over R effective here, okay? So we are going to have the power is equal to the potential difference across the two resistors V times I, but in this case, we replace it with V over R effective. So V over R effective. Now we can simplify this further. So V times V is V squared, and then times 1 over R effective. So this is very straightforward. We know 1 over R effective to be equal to 1 over R1 plus 1 over R2. So we can plug that in here, and we are going to have V squared multiplying. So this, or 1 over R effective here, is nothing but this thing here. So we need to import it all the way here to find that, okay? So with that, we are going to have, okay, so multiplying 1 over R1 plus 1 over R2. So this will give us a final result of the power to be equal to V squared multiplied 1 over R1 plus 1 over R2. And this gives us the total power dissipated in the electric circuit. All right, so clearly from this problem, we can see that the effective power is given by option A. Okay, so this brings us to the end of this video. If you are new to this channel and you find this helpful, please give us a thumbs up and also share. If you are already a subscriber or part of this community, thank you very much for your support. And until then, I will see you in the next video.